Welcome to Unit 4 guided practice in the remediation practice. It says define the following terms. Momentum. Momentum is a product of the mass times velocity. Mass is the amount of matter that a system contains. Velocity is the rate of speed over time. A vector is a quantity that has both direction and magnitude, and a scalar quantity is just a number, it doesn't have a direction to it. When we are looking at our system, the system is what is being observed. A collision is when you have two objects that collide with each other. An explosion is a specific type of momentum equation where your initial momentum is zero and things blow up. And then the conservation of momentum is just saying that our momentum before has to equal our momentum afterwards. So defining momentum, what two variables are required for an object to have momentum? It must have mass and it must have velocity. So it has to have mass and velocity. Which objects have the greatest momentum? Well, a 1 kilogram basketball moving at 10 meters per second. Well, momentum is just mass times velocity. So 1 times 10 would give us a momentum of 10 kilograms meters per second. 8 times a bowling ball times 5 would be 8 times 5, which is 40. And then a 1200 kilogram car at rest. Well, it's at rest, so therefore its velocity is 0. So what has the greatest momentum? Well, that would be our bowling ball. It says light is a massless particle. It can't have momentum. Well, why don't you answer that question? Looking back at our saying that momentum is mass times velocity. Calculating momentum work. It says calculate the momentum of a 0.1 kilogram basketball moving at 35 meters per second. So we have our momentum is going to equal our 0.1 times our 35 meters per second, which will give us 3.5 kilograms meters seconds. Next one, calculate the momentum of a 5 kilogram bowling ball moving at 8 meters per second. So all it is just kilograms times meters per second. So 5 times 8 is 40 kilograms meters seconds. And then lastly, which has the greatest momentum? Refer to the one we did way up here, and then just use it by doing mass times velocity. Whatever is the greatest number, that will be the answer. Combining momentum. What is the total momentum of a system? When they are going in the same direction, we add their momentums together. When it's going in opposite directions, we subtract them. So 150, they're going together, so the momentum is 150. They're going opposite each other, so we subtract, and we get 125 minus 60 will give us 65. What additional vector is required to bring the momentum of the system to 0? Well, remember that if it's opposite, that means that the total momentum of just these guys is 205 times 70, which is 275. So this would have to be 275. Moving on to collisions, it says collision is momentum conserved in a collision of an object in a closed system. Yes, all momentum is always conserved. B, it says the total momentum of the system is 10, so our momentum total before has to be our momentum total afterwards. So before it is 10, and afterwards it'll have to be a 10. So we know that A is 14 plus our unknown would be B. So solving for this, B would have to be negative 4. And then C, a bumper car moving at 10 meters per second collides with a second bumper car of 200 kilograms. The bumper cars stick together. What is the velocity after the collision? And so when we're looking at this, the momentum before is just going to be 1,000. And so our momentum afterwards is going to have to be 1,000. And so therefore, but our mass has changed, and now our mass is going to be our 220. And so what is our velocity? So all it would be is just our 1,000 divided by our 220, which would give us a velocity of around 4.55 meters per second. An explosion. An explosion, it says, is momentum conserved in an explosion in a closed system? Momentum is always conserved. It says the total momentum of a system is 0 kilograms before an explosion. Fragment A moves at 136 kilogram meters per second. What is the momentum of fragment B? And so this is 0 equals 136 plus B. So that means that B would have to be negative 136. It's moving in the opposite direction. And then lastly, we have C, which is 1 kilogram of paint is rolling along a floor at 2 meters per second. After an explosion, a 0.1 kilogram fragment moves forward at 20 meters per second. What is the velocity of the second fragment? I'll set this up. So this is rolling along, so it does have an initial momentum of 2 kilograms meters second equals a fragment keeps moving forward, 0.1 times 20, which would be 2 meters per second. What is the velocity of second fragment? We'll just call it x. So solving for this, we see that x is going to have to be, take this, subtract it from that, x would have to be 0.